This lesson covers different methods to iterate through tables, focusing on the differences between pairs and ipairs, and how to use for loops to iterate over tables. Pairs function is used to iterate over all key value pairs in a table, regardless of whether the keys are numerical or non-numerical. Ipairs function is used to iterate over elements in a table with numerical indices starting from 1. It stops at the first nil value encountered. The pairs function allows you to traverse all key value pairs in a table, which is especially useful for tables used as dictionaries. Note: it is normal for the output of the pairs function to be different each time you print the elements of a table in Lua. The pairs function iterates over all key value pairs in a table, but the order in which the pairs are returned is not guaranteed to be the same every time. This is because Lua tables do not maintain a specific order for their elements when accessed using pairs. If you need to iterate over elements in a specific order, you'll need to manage the order yourself. One common approach is to store keys in an array and sort them before iterating. My table contains our key value pairs. A new array keys is created, and all keys from my table are inserted into it using the pairs built-in function. The keys array is sorted alphabetically. The sorted keys are used to access and print the corresponding values from my table in a consistent order. In the provided example, we are using a generic for loop. In Lua, a generic for loop iterates over all values returned by an iterator function. Both pairs and ipairs functions are examples of iterator functions. This way, you can control the order in which the elements are processed. The second loop iterates over a sorted list of keys from my table, using the underscore placeholder to ignore the index and directly access each key. It prints each key and its corresponding value from my table, ensuring a consistent, ordered output. The ipairs function is suited for iterating over tables with consecutive numerical indices starting from 1, such as arrays. In this example, the indices are 1, 2, 3, and 4, which are consecutive and start from 1. Using the ipairs function to iterate over this table will visit each element in the order of these indices. This loop will print each index value pair in the array in the order of their indices, confirming that ipairs is ideal for tables with consecutive numerical indices. Another approach to iterate over elements in an array or a table with consecutive numerical indices is by using a numeric for loop. This loop gives you precise control over the indices and can be particularly useful when you know the range of indices you want to iterate over. The loop starts at I assigned to 1, which is the first index of the array. It continues as long as I is less than or equal to the length of my array. After each iteration, I is incremented by 1. In each iteration, the current index and the corresponding value are printed. Both ipairs and numeric for loops are suitable for arrays, but numeric for loops offer more control over the iteration process. Dictionary-like tables are those where keys are not necessarily numerical and can be strings or other types. Using the pairs function is ideal for dictionary-like tables where you want to iterate over all key value pairs, regardless of the key types. This makes pairs versatile for accessing elements in tables where keys are not consecutive numbers. My table is defined as a dictionary-like table with string keys, name, age, city, and their corresponding values, Alice, 30, Wonderland. The pairs function is used to iterate over all key value pairs in my table. In each iteration, k is assigned the current key, and v is assigned the corresponding value. The print k, v statement prints the current key and value. The output may vary in order because pairs does not guarantee the order of iteration. Pairs and ipairs functions, along with generic and numeric for loops, are indispensable tools in Lua for efficiently traversing and processing data stored in tables, catering to a wide range of use cases and programming scenarios.